Hello everyone, welcome to Master to Teach Step-by-Step Guide. In this video, we are going to learn what is sequence diagram, what are the different parts of sequence diagram. We will go through one by one. How to draw sequence diagram, we will see step by step. We will also see an example drawing sequence diagram with case study. I will try my best to explain step by step. If you haven't subscribed to our channel, please click on the subscribe button and subscribe to our YouTube channel. Okay, let's start. What is sequence diagram? Before starting, I would like to make clear that the sequence diagram is also called as an event diagram or event scenario. The UML diagram, which shows an interaction between objects arranged in the time sequence, is a sequence diagram. Sequence diagram illustrates how the different parts of the system interact with each other to carry out a function and the order in which the interaction occurs when a particular use case is executed. As I have already mentioned in my previous video tutorial of communication diagram, sequence diagram and the communication diagram are the type of interaction diagram where it shows how objects of the classes communicate by sending and receiving messages. Also, I have already mentioned that these two diagrams, communication and sequence diagram, are isomorphic, which means you can convert one diagram into another diagram. So far, we have gone through how to draw use case diagram and how do we write high-level and expanded use case description in the previous video tutorial. If you haven't gone through it, please find the link above or in the description of this video and go through it before you start sequence diagram. After the expanded use case description of the major use cases, we can start either the communication diagram or sequence diagram so that you should know what is expanded use case description and how to write it. Expanded use case description is a two-way interaction steps written between the actor and the system, how that particular use case will execute. We have already drawn the communication diagram in the previous video. Now let's draw the sequence diagram. The sequence diagram is an interaction diagram that shows details on how operations are carried out, like what messages are sent and when. It can be drawn at different levels of details and to meet different purposes at several stages in the development lifecycle. It typically used to represent a detailed object interaction that occurs for one use case or for one operation. We all know that objects of the classes communicate by sending and receiving messages. Let me show you an example how objects of the classes communicate by sending and receiving messages in coding. Here is class A with method name as method A, which will perform certain tasks. Another class B with method name as method B, which will also perform certain tasks. Now another class C, which is the main class or controller class. Here, new object A of class A is created. Also, new object B of class B is created. A.method A, where C says to A that method A should be executed. Answer is called to B.method B. C says to B that method B should be executed and B returns the results to C, which is stored in answer variable. In this way, objects of the classes communicate by sending and receiving messages. I hope you are more clear about how do the object communicate. And showing this interaction of the object's message sending and receiving stepwise arranged in a time sequence is a sequence diagram. A sequence diagram is structured in such a way that it represents a timeline that begins at the top and descends gradually to mark the sequence of interaction. Each object has a colon and the messages exchanged between them are represented with arrows. Let's go through each and every part of sequence diagram step by step. Number 1. Dimension. A sequence diagram is drawn in two dimensions, horizontal and vertical. Object dimension. The horizontal axis shows the elements or objects that are involved in the interaction are listed from left to right according to when they take part in the message sequence. They can be appear in any order in the horizontal axis. Time dimension. The vertical axis in the sequence diagram shows the time from top to down. Note that a sequence diagram is all about the ordering, not duration, so that while drawing sequence diagrams, we have to be careful on timing and ordering, but we don't mention the duration of time on it. Actor. Anyone who used to perform a certain function in the system is actor. Actor may be someone or something that can be a person, an organization, another system, machine, or any external device. So, who or what is going to use our system is actors like customer, staff, admin, bank, student, teacher, etc. The actor is representing by the human stick image as same as in use case and communication diagram. Lifeline. A lifeline represents an individual participant in the interaction. A lifeline is shown using a symbol that consists of a rectangle forming its head, followed by a vertical line which may be dashes that represents a lifetime of the participant. They represent the different objects or parts that interact with each other in the system during the sequence. The standard in UML for naming a lifeline follows the following format: instant name, class name. It represents the passage of time as it extends downward. As the object is destroyed, the lifeline ends there. No two lifeline notations should be overlap each other. A lifeline notation with an actor element symbol is used when the particular sequence diagram is owned by the use case. Activations. A thin rectangle box on a lifeline represents the time needed for an object to complete a task. Simply, we can define as the execution of an operation. The top and the bottom of the rectangles are aligned with the initiations and the completion times respectively. It reflects the time of execution so that the activation box becomes longer as the task is longer. Message. A message defines a particular communication between lifelines of an interaction, which means showing how the objects interact with each other by sending and receiving messages. The messages appears in sequential order in the lifeline. We represent messages using arrows. We can further classify the messages as follows. Synchronous messages. Synchronous messages represented by a solid line with a solid arrowhead. This symbol is used when a sender must wait for a response to a message before it continues. The sender waits until the receiver had completed the processing of the messages. The caller continues only when it knows that the receiver has processed the previous messages. That is, it receives and reply message. The diagram should show both the call and the reply of the messages. Asynchronous messages. An asynchronous message doesn't wait for the response from the receiver before the sender continues. The interaction moves forward irrespective of the receiver processing the previous message or not. We use a line arrow to represent an asynchronous message, and only the call should be included in the diagram. Return message. A return message is used to indicate that the message receiver is done and is returning control over the message caller. Note that returning messages are optional notations and only triggered by the synchronous messages. You can avoid cluttering up your diagram by minimizing the use of return messages, since the return values can be specified in the initial message arrow itself. Create message. An object can be created at any times of execution of the process. To represent the new object created in the process of execution, create a message is called. It is represented by a dashed line with a line arrowhead and label with word create on it to specify that it is the create message symbol. Reflexive message. Sometimes an object needs to communicate with the same class method. That is, when an object sends a message to itself, it is called the reflexive message. It is indicated with a message arrowhead that starts and ends at the same lifeline as shown in the diagram. Object destruction. As soon as the object does not need any more in the further process, object destruction is called, which is deleting the object. Object destruction represents the request of destroying the lifecycle of the target lifeline, which is shown by the cross line, and there will not further lifeline symbols mean dotted line. It destroys the occurrence of the objects in the system. Comment. A comment or a note can be used to reflect the various marks to the elements. A comment carries no semantic force but may contain information that is useful to the modeler. The comment object is a rectangle with a folded cover corner, as shown in the diagram. The comment can be linked with the related object with a dash line. Now let's move further. Focus of control. The focus of control indicates times during activation when processing is taking place within that object. The focus of control is also known as an execution occurrence. It represents the period during which an element is performing an operation. The top and the bottom of the rectangle are aligned with the initiations and the completion time respectively. The focus of control can be shown as follows. The white gap in the activation reflects the waiting time and the shaded with black reflects the execution time. Control object. The control object is to manage the collaboration of the objects, which gives effects to the use case process. The name of the controller object is the same name as the use case name. Like control object for the use case enroll student is : enroll students. Don't forget to underline the text as well. Boundary object. Most use case implies at least one boundary object that manages the dialogues between the actor and the system. Boundary object will also have the same name as the use case name with the additional of UI at last, like : enroll student UI. This object is for the user interface. Control object and boundary object are similar as the communication diagram. Now let's learn further more advanced in the sequence diagram. Guards. When modeling object interaction, there may be the certain condition that must be met for a message to be sent to the object. To model conditions, like if condition in programming, we use guard in sequence diagram. Guards play an important role in letting software developer know the constraints attached to the systems or a particular process. For example, in order to withdraw cash from the bank, the account balance should be greater than 0. So, balance greater than 0 is a condition that must be met for this message to be called, which can be shown in the sequence diagram like this. Alternative. In guard, we represent the if condition in the diagram, whereas alternative in sequence diagram symbolize a choice between two or more messages sequence. To model a choice of the message with a condition like if-else condition in programming, we use an alternative. The alternative's fragments is represented by a large rectangle or a frame. It is specified by mentioning ALT inside the frame's name box as shown in the diagram. To represent alternatives, use the label rectangle shape with dashes line inside as shown in the figure. Only the one whose condition is true will execute. Optional. Optional is similar to guards where the fragments execute only if the supplied condition is true. Guards are used only for a single message, whereas optional is used to model fragments of the process as shown in the figure. It is represented by a large rectangle or a frame where OPT is labeled inside the box similar to the alternative. In the alternative, there are if-else condition, whereas in optional there is only if condition same as guards. Parallel. In parallel, each fragment is run in parallel if the condition is matched. Each fragments are the message will execute parallel. The notation of parallel is similar to the combination of optional and alternatives where there will be the only one condition as optional and multiple messages or fragments as alternative. It is also represented by the large rectangle where PAR is labeled inside the box as shown in figure. Loops. The fragments may execute multiple times which may be need to model in the diagram. Sequence diagram has been improved with the addition of the loop combinations fragments. Loops fragments is used to represent a repetitive sequence and it is very similar in appearance to the optional. For loops, draw frames and inside the frame's name box, label with text loop. Inside the frame's context area, the loop guard or condition is placed towards the top left corner as shown in figure. The loop sequence of the messages is placed in the remainder of the frame's context area. In the loops, there can be two special conditions tested against in addition to the standard Boolean test. The special conditions are minimum iterations written as min_int is equal to the number like mint_int is equal to 1 and the maximum iteration written as max_int is equal to number like max_int is equal to 10. With a minimum iteration guard, the loop must execute at least the number of time indicated, whereas the maximum iteration condition, the number of loop executions cannot exceed the number. Sequence diagram. The entire sequence diagram is surrounded by the box or frame, and inside the frame's name label with text SD: process name. Beside this, there are other notation like negative. The fragment shows an invalid interaction. Another type is reference. Reference refers to an interaction defined on the another diagram. The frame is drawn to cover the lifelines involved in the interaction. You can define parameters and a return value. So using these all elements, we can draw the sequence diagram. How to draw sequence diagram? Now let's move to learn how to draw sequence diagram. As I have already mentioned you before, the sequence and the collaboration diagrams is derived from the high level and expanded use case description of the use case. Let's take the same use case example which we have drawn in the previous use case tutorial. It's a college student record system application where students can enroll online in the college themselves from home. The high level and expanded use case description of the use case enroll students are, as we know, in expanded we write interactive description between the actor and the system. Number 1. The new students provide personal details for enrollment. Number 2. System responds and shows available course as options. Number 3. Choose the best course among the available course. Number 4. The system provides a confirmation message of enrollment to students. So, the first step is go through the use case description and list the domain classes. How to find domain classes? I have already explained in details regarding how to find domain classes in previous video. If you haven't gone through it, please find the link just top right corner of this video or in the description below. The major class which needs to define while executing the use case are the domain classes. Now, first of all, find the nouns from the description and list those which are important to the processing. If the system has to process data about the type of person or the object name, then this is probably the relevant class of the objects like student data, needs to store, course options should be provided, and chosen courses data need to process. The possible classes of the use case enroll students are number 1 student, number 2 course, and number 3 enrollment. After successfully identifying all domain classes, we need another 2 classes to manage the collaboration of objects which gives effects to the use case process. It's a control object. To manage the screen interactions for the use case, it's a boundary object. So, the first step of drawing sequence diagram is finding the domain classes, whereas the second step is drawing controller object Lifeline. Add a control object in a diagram. Note that the name of the controller object is the same as the use case name. Here we are taking an example of enroll student use case, so the controller object name must be enroll student. The next step, which is the third step, is drawing boundary object Lifeline. Boundary objects will also have the same name as the use case name with the additional of UI at last, like enroll student UI. The object is for the user interaction. Now, the fourth step, where we draw the actor lifelines just beside the boundary object because actor interacts with the system interface. Actor notation is similar to the use case diagram, which is represented by the human stick image, and lifeline is drawn with thin rectangle box as shown in figure. Now moving forward to the fifth step, which is adding messages to the diagram in time sequence from top to bottom. We assume that the user interface was started up by the menu process. Then perhaps the first message might be displaying enroll form to the user in the boundary object Lifeline. The control object, the boundary object, and the actor are appearing simultaneously so that they are drawn in the same horizontal line. The user or actor will fill out all the required information and send to the controller object by interacting with the boundary object, which is shown in the sequence diagram as follows. Note that in sequence diagram, the particle flow represents the time flow so that the arrow of message passing and returning can't be drawn tilted upward position. It can be drawn in straight position as well as tilted little bit downward position because every lines of code execution and calling method take time. Once the user has entered all the information like name, address, etc., the data might be sent to the controller object using the message record personal details. I am following the camel casing naming convention here, and there should not be any space between the letter. As you can see, at last we end with the parenthesis. It's a method name where we can show the passing arguments as well. Also remember that the messages are shown in the serial wise. Like at first, display enrollment form methods is executing, and after that the actor fill personal detail method is executing, and after that record personal detail like this. The activation box symbolizes the time it will take to perform that task. There is not exact measurement of time, as I have already mentioned you before. It only reflects the time it will take to execute the process. Small box is for the small time, whereas long box for the more time to execute the process. Let's move forward. The control object will create a new object of student class to store all the info provided by the students. So the next step, which can be numbered as 6 step, drawing domain class object Lifeline. Note that it is called by the create message and draw the object Lifeline in the same horizontal position where the object is created. The sequence diagram shows when the new object is created. The control object will call the constructor automatically as soon as the new object student is created, which can be shown as in figure. While control object calls the constructor of the student class, control object has to wait for finish executing and return message from the student object Lifeline, which can be shown in the figure like this. It is called as the focus of control. As soon as the control object gets the return message, it will create a new object for the enrollment. Similar to the student object, we can show in figure as follow. Constructor of the enrollment class will auto call when new object is created by control object. Next step is control object needs to display the list of courses available to the student in the boundary object. So controller object creates a new object of class course and call for the get course details. Here, multiple course has multiple information to display, which means need to create multiple objects to store their respective information, which we can show in loops in sequence diagram as shown in figure. Note that we mention asterisk in the communication diagram for the iteration. After control object gets return message from the course Lifeline, it passes to boundary object to display in the screen for students. Student will choose the desired course and submit to control object from boundary object. The control object stores the chosen course to the same student enrollment object. At last, place these diagrams in the frames with SD: enroll students label on it. In this way, we can draw the sequence diagram following step by step. Note that the sequence diagram depends on how the analyst chooses to allocate responsibilities between the objects and the chosen order of processing. It would be possible to draw an entirely different sequence diagrams to the same task. And if both sequence and collaboration diagram are prepared, they should be consistent. I hope you learned from this video tutorial. If you have any questions or comments, please make sure to leave a comment in the comment section below. Also, please be sure to like this video and subscribe to my channel if you haven't already. Thank you very much for watching. Check us out for more in IT tutorial and guide on website master2teach.com. And we will see you again soon. Bye.